Hello, Ashlyn Artificial. I'm just getting set up a little bit right now. And then once I got everything up, I'll give a little intro on where we left off and what we're going to be doing for the next 2 hours. Cool. So yeah, last week we started working on this enemy, which is like a jet that spawns like behind the player along these sort of spline tunnel sections, and then it's going really fast, so they shoot in front of you, and then they continue following the spline as they go along. And then I did a little bit of extra work after we finished the stream to get them. Here you can see they were clipping through the terrain before, so now I updated that. So if you look at some of these, they're still spawning. Okay, here, wait, are they coming around? Yeah, like if you look at some of these outcroppings that are pretty close to the spline, now when they crash into it, they kind of like orient and move out of the way. So nobody's flying through the landscape anymore. And so what I want to do now is change their AI so that they shoot out in front of you, and then they stop in front of you, and then they turn around, and then they start shooting backwards, like back at you. And to facilitate that, I just went into Maya real quick the other night, and while I was watching some anime, I made this quick little wasp rig. So you can see he's got wings, he's got a head that can look around, but importantly, she's got this big tail here where she can go whoop, and then, like, you know, shoot you. So I think the first thing that we're going to do on the stream is I'm going to export this character. Maya saves like 3D models as like a Maya file, but then you can like bake it into a thing called an FBX file that Unreal knows how to read. We can import that. We can replace the model. Then I want to like do some animation work, like get its sort of like wings going. Then we'll go into the code to get them like changing state from like the approaching you from behind state to the shooting you from in front state, at which point like I'll make like a little animation that looks like this, that will kick off so that it actually aims at you. That's the plan. As always, we go on Fridays for about 2 hours. Sometimes we go a little bit longer if we're in the middle of something interesting. If you ask any questions in the chat, I'll just read it out for everybody. We put stuff on the Twitch video on demand, so it's usually up on Twitch for like 1 or 2 weeks after we're done, and then we also have a YouTube channel where we have an archive of all the streams that we've done. So this is actually like part 3 in like a series on making these like rail sections, if you want to go back and watch part 1 where we did branching stuff, and part 2 where I did spawning the enemies. I'm setting up the material for the character right now, by the way. So there's like a base, color texture, there's an emissive texture that I'm going to use to make its eyes glow, and then I'm going to use this material function that I call like damage, which is just like a little shader snippet that lets it flash when it gets hit. So this tool here is called the Animation Blueprint Editor. That's in Unreal, and it lets you write these little programs that compute how the character should be posed. It's pretty easy to use, and it's pretty nice because they run on background threads, so it's relatively efficient. I'm just going to do a thing real quick where I compute like an oscillating signal and then plug that into the rotation of the wings, just as like a quick and dirty animation to make them flat. So just to explain this math that we're seeing here, I'm taking the current time, I'm multiplying it by like a big number, that's the frequency, I'm plugging that into a sine wave generator to give us a number from -1 to 1, and then I'm multiplying that by 45 degrees, which is the amplitude. And then I observed in here, if we like look at these, like the X rotation is the axis, the like flapping axis. So we just plug this into rotation X for like these little special modifier boxes. This is modifying wing left and wing right. And then we simply take our base animation, we plug it in as the input, we take the result, we plug that as the output, we hit go, and then it complains. Oh, because I forgot to do a setting. I want to actually add that. So there we go. It's looking a little bit silly because we actually don't want them to have the same rotation. We want them to have opposite rotations, so one of them needs to be negated. Okay, so now I think it can probably flap faster, so I'll increase the frequency. It's maybe too fast. There we go. I think another thing I might do real quick is just give it a little bit of like an idle, like up and down, like sort of oscillation on its main body. Just like not anything that you would notice, just enough that you're not noticing that it's perfectly still. Cool. I think that's pretty good as like a sort of basic temp animation. So next thing, I just want to go into the character blueprint for those jets and replace the jet mesh with this new wasp mesh. There we go, we got guys. So I think the next thing is that they don't actually have hitboxes, so I can't like actually shoot them. So I'm gonna set it up. I'm gonna set them up with hitboxes, make it such that I can shoot them, and then make a little explosion when they blow up. Man, I'm playing like a YouTube mix that says it's all DMCA, like Twitch-friendly music, but I don't know. This seems a little too close to the normal Terrytown theme. I'm kind of worried that it's gonna show up. I don't know. Let's roll the dice. Let's see what happens. Cool. So we can missile target them. They blow up. They have a big green blob explosion. Maybe that's too big. And you can shoot them, and they flash when you shoot them. So I think at this point we've done like the basic setup for the wasps. So the next part is we're gonna have to write some code. I'm gonna go back to the state machine for them, and right now they're just in this approach state where they're just trying to go in your direction and faster than you. Now I want to say like, okay, if you're like in front of the player, turn around, zip, and then basically just maintain distance in front of the player. I'm also gonna have to turn off the like infinite spawn and make sure to cap it at like, you know, 3 or 4 concurrent instances. So this is how I write the AI code in C++. I have just like a single virtual function for each enemy type, which is handle event. It gives you an event. I combine these events with my current state so that I get like a tuple that I can switch on, which is like, oh, I've entered the spawning state, or I've entered the approaching state. So basically I want to add the condition to the approaching update here, which is that when I'm far enough in front of the player, I should swap to this like turning around state before being in this out front state, right? So as always, if you want to know more about like how this is working or just like programming in general, can answer questions about that, or if there's anything you saw earlier when we were setting up the wasps, you can look at that too. Just ask me anything. First thing I'm writing here is just a function that says like I want to get the difference between two distances along the spline, which seems like it's just their difference, except you need to consider that the spline could be a loop, so it can wrap back around. Yeah, so basically all we're doing here is we're taking the difference. If it's not a closed loop, we're done. If it is a closed loop, then I get half the length of the loop. And like if your difference is more than half the length, I like add or subtract the length to make sure that we're always, you know, like maybe you're like almost half a length ahead and then you like jump forward a bit. Now you're like more than halfway ahead, right? Like it's actually shorter to consider you less than halfway behind them at that point. So that's what this logic is doing. What I'm doing, by the way, is I'm updating my aggro component. This is a component on any actor that like notices another actor and acts aggressive towards them as part of the combat system. I'm just, rather than doing all the normal like aggro logic, I'm adding like a scripted thing where I can just like force an aggro component to aggro a specific actor, because we know exactly the player that like triggered you when you get spawned, so we'll just lock you to aggro the actor that you spawned behind. This is one of those things that like seems unnecessary until you start thinking about multiplayer, like, oh, which player is the enemy shooting at, and then it becomes important. cool. So I think you can see it there. Basically what's happening is they get like right in front of me and then they stop. Here, I'll make them go a little bit further so you can see it. But that shows that we've swapped from the approaching state to the, where are you, buddy? Wasp. Yeah, right now I have them going 10 meters. I can go 20 meters in front of you. Or 25. A meter is just the length of my ship, so they'll just be 25 lengths in front of me. Or maybe not. Is there something weird? Oh, I think it might be weird when I'm going backwards. I gotta check on that. But yeah, so you can see they're in their approach state. They get far enough ahead of me. They swap into their turnaround state. Their turnaround state has this very elaborate nothing happening, so they just kind of like sit in place. So what we're gonna do now is we're gonna just like update their distance to be like in front of the player. We'll move their position to match that distance, and then like what was I gonna say? We'll just yeah, have them maintain that distance in front, as well as like rotate around so that they'll face us. I think I'm gonna get rid of this like turning around versus out front distinction. I'm just gonna call that the out front state and use the time that you're in that state to change up some of the other logic. I think maybe distinguishing them is just gonna lead to me duplicating code. I might be wrong about that. Might have to split them out again later, but that's what I'm gonna do for now. Oh, I see why it was a problem with reversing. It's because I tell them the direction to go around the spline, but then I'm not actually using that anywhere. So I'm gonna fix that real quick. Sorry for the weird typos today. I'm weirdly jittery. I'm just doing some really hacky math here. I can't really explain it other than like I'm trying to do a low pass filter on the position of the character with some lag compensation and then messing with the numbers in order to make collision happy. I don't think that this is necessarily a good idea. I just want to see if this works at all as like an initial sketch. This is like when an artist is just sort of scribbling something in that's like not quite figured out yet. By the way, if you're wondering why I keep typing pi in, it's because those units, this is a rotation, those are radians. So like pi is like 180 degrees, it's flipping around. So if you're going around the spline the opposite direction, you're rotated by pi. Okay, well they all shot out in front of me and then stopped, so let's see what's happening there. Okay, so I rebuilt for debugging. Now we can like step through what's happening in this state, see why they're not moving. Oh, actually, I'm an idiot. As soon as I said that, I realized the reason is because I'm not actually calling the function that actually moves the actor. Okay, I'm so smart. Okay, so there we go. They're all hanging out in front of me. They're maintaining their same like offsets from the spline. They're relatively smooth because I put a low pass filter on them. For testing, I don't have collision in this state yet. That should be pretty easy to add. So I think the next thing that we need to do is that when they get into this state, oh yeah, they're already clipping through stuff. I need to fix that. But when they get into this state, and like maybe I'll, what happened there? Oh, that's got to be right around, yeah, I think this is where it loops around. So actually, that's a good point. I need to handle that distance looping around. Okay, I'm so smart. But once we get that, then Yeah, we want that tail to come down. I'm actually gonna make him get a little closer to the player. Take this down. So we'll like author an animation of that tail coming down. Let's fix that bug we just saw where they got stuck on the loop. I think these guys, I think it might actually be better if they're bigger. I might get rid of, I scaled them down like 2/3, but I think the original size was actually good. Also making your hitbox a little more generous here. I'm just updating it because they when they get killed, I'm going to remove them from their squad on the spawner, and then the spawner can see like, oh, there's room in the squad to spawn new ones. So as I kill them, yeah, it'll just keep bringing sort of more out. Okay, let's go back into Maya and add that animation. Yeah, so the first thing I did was I referenced that model into a new Maya file, which will be a file specific for the animation. You see it looks kind of scrumbly like this. That's because Unreal characters are authored with centimeters, but by default Maya is configured for like meters or like feet and stuff. So all you need to do is go to your perspective camera and change the near clip plane to 1. And now you can see the clip space is saturated, and you're not getting those sort of like glitches that you get from being sort of like bad precision in the perspective projection frustum. I'm just showing off that I know jargon. Anyway, so now we'll just go in here. We'll, let's see, let's x-ray joints so I can see the joints. And we're going to grab all these joints. I think I want to give them like a little more anticipation to this animation. So I think I'm going to have them like, so he's going to like go like up and down a little bit as they're rotating around so that it's like more obvious to the viewer. I don't need to be like too careful about this. This is just like a temporary blockout mesh, but I like to sort of, when I'm doing like prototyping and blockout, to at least focus on stuff being legible. Yeah, so this curve right here, this shows that sort of like vertical movement. I think I want to play with the timing. So it like pops up, slams down pretty quickly, but then has like a very sort of gentle fall off on the other side here. What did I do? There we go. I think that's a pretty good animation of like, gonna like do a little jiggle. So you notice that they're like changing state, and then he's like pulling his little tail under to point at you. Oh, but it looks like it's not quite pointing forward. Let me get it just right. There we go. It's got a little bit of overshoot and easing. It's got a little bit of secondary animation in the head. the tail's pointing, the wings are tilting a little. I think this is good enough for government work. So I'll save this. It's gonna be wasp, curl, select my bones, export selection. Import the assets. Oh, on my Maya workspace, characters, wasp curl. It's on the wasp skeleton. Everything looks good. Yeah, there we go. Look at this cutie. Okay, sorry, enough admiring. Let me fix it up with my naming convention. These names are just like everything in Unreal, just has the extension .u asset. It's really annoying. So there's like, you can find, there's like a GitHub repo if you just search like Unreal naming convention, where everybody's sort of agreed on all these prefixes for different file types. So A for animation, ABP for animation blueprint, BP for blueprint, M for material, Fizz for ragdoll, SK for skeletal mesh, Skell for skeleton, T for texture. So let's go to our animation blueprint. And now, instead of just applying an animation, like a single animation, we're gonna add a state machine. And we're gonna call this state machine pose. And there's idle. And then there's tail curled. So we have our default animation for that. We have our tail curled animation, which we do not want to loop. And then the transition between these, I don't need any crossfading. And the condition, I'll create a variable here called want tail curl. Want tail curl. Great. We can preview this. Preview does nothing because I didn't plug it in. But by the way, all this like breathing loop and like flapping stuff, these are all still, it's like, why can't I? There we go. That was weird. This is all just like modifiers that are post-processing the pose, so this will be applied in both cases. But now, should be able to tail curl. There it goes. Oh, we want to have another transition to go back. So we do not want the tail curled. We go back and we'll just make this, we'll just cheat for now. We'll do like just a linear crossfade. So boop, it's got that, and then he just sort of blends out when you want to go away. Boop. I don't think there's like a case where we want to revert them, but you never know. Look at our little cutie. Oh my goodness. Great. So now we just need to have the game set this flag when we enter the approach state. So I'm just gonna set up an event for that. So you make events in C++ and Unreal by saying u function blueprint implementable event. So we'll have this wasp will turn around event. And then when we enter this out front state, we're just going to fire that event. Wasp will turn around. And let's build the game again. We'll go to our blueprint for the wasp. Now watch this magic. I can say wasp will turn around. Now we have like an event for it. We can take this, we can say get anim instance. This is the animation blueprint instance. We can cast it to ABP wasp. We can call this, actually, we can just make this a pure cast because we know it's going to succeed. And then here we can say set want curl. Yes. So this is my like general structure for everything. Like the code is like totally in charge of the gameplay. The blueprint basically just handles events and kicks off like VFX or sound effects when they happen. So this is just like all the wires behind your VCR, plugging everything into everything else. And then you have all the materials and the animation blueprints and the other things like actually handle like what it means to show this stuff. So now we go, they come forward, and they turn around. I don't like how they're turning around too soon, so I'm going to put a delay in here. And let's say like 1 second after they turn around, we're going to tell it to curl its tail. Okay, that's a little too late. Maybe a half second. Well, that's still a little too late. Let's keep having it. 1/4 of a second. Whoop, I lost my escape key. Before cheap keyboard. Still think this is too long. Let's have it again. 0.125, an 1/8 of a second. Yeah, that looks pretty good. I don't like having this arbitrary delay in here though, so I think what I'm going to do is just build that delay into the animation. So we have 30 frames per second is our animation rate. 30 frames per second times 1/8 is, this guy had 4 frames to the front of this, so let's just change this to be a 35 frame animation. Let's go to the animation graph. Select everything. I'm just gonna move everything over. So now it's got like it's like a little heartbeat before they turn around. So we know this is the part where they're like actually rotating. I wonder if there's anything I want to do there. And I'll just leave it alone for now. But we select everything, we re-export it. Go back to the game engine, we re-import it. And then when we play, even though we don't have that delay, they still look a bit better. So we're almost at time. I like how they all kind of push each other around. I need to add some squad mechanics so that they coordinate with each other. But so I think like this is maybe a good place to leave it for now. We like kind of got a lot done, but actually no, I'm looking at it. Those wings are too slow. This is not like wasp wings. They need to be faster. What was I thinking? Let's go back here. There we go. Is that going to be better? Yeah, that's a little better. So anyway, I think this is a good place to leave it for now. Like obvious next steps, like they need to be like slowly pumping out bullets so that you're like dodging. I think also they're maintaining like a fixed horizontal offset from the spline, and we need them to actually like make patterns with each other and also kind of follow you around. Like if I go to the right, they should all go to the right, and if I go to the left, they should all maybe try and go to the left. Also, I think their collision, like it technically works, but like boy does that look glitchy and goofy, so I want to fix that. But yeah, in general, I think we're like, this is like a good starting point. And like it'll be fun next week to give them like a little more logic to like know when to shoot you, know how to kind of point at you, know how to kind of chase you around the screen, know how to like fly in formation with each other. That'll be like a lot of like fun stuff. It'll give me an excuse to explain a lot of math things. So yeah. Why is it so hard to walk onto these guys? I should look into that. But thanks for coming on the stream. Thanks for watching. We'll put this up on VOD if you like came late. We also like archive everything on YouTube. If you don't know about us, you can follow us at Tiny Galactic on Twitter. You can find a link to the Discord there. There's like an ongoing devlog and AMA thread there, and yeah, we're working on all kinds of stuff, including like secret stuff that I don't have put on the stream yet. But yeah, Hopefully we'll have like more announcements about the project soon if you're just like interested in the general progress of things. And yeah, thanks for watching. This was fun. Go. I'm clicking the button now.